Hello everyone. I hope you're having a good day. Welcome back to my channel. Today we're going to talk about center of gravity in 3 dimensions of a solid or a volume. Here's the problem statement that we will be working through together. So let's get started. So some things to review first are the centroids of common shapes and volumes. Here we can see a hemisphere and a semi-ellipsoid of revolution. Continuing on, paraboloid of revolution and cone. And finally, a pyramid. This is a problem statement. A bronze bushing is mounted inside a steel sleeve. Knowing that the specific weight of bronze is 0.318 pounds per inches cubed and of steel is 0.284 pounds per inches cubed, determine the location of the center of gravity of the assembly. So we want to determine the location of the center of gravity of the assembly. Unit analysis, it's helpful to review unit analysis first. So the weight of something is equal to the volume of that object times its specific weight, because we can see pounds, the weight for the unit for weight, equals inches cubed, the volume, times pounds per inches cubed. So that leaves us with pounds. So problem statement again, this is a problem statement, and then it's helpful to review the centroids of weight of an object with weight. So the x-coordinate of that centroid is equal to the sum of the x centroids times a very small weight divided by the overall weight of the whole object. Solution. First, we want to divide the overall shape into cylinders. Blanking out the whole object, we can see that we can reduce it to a shape like a hat. Moving that shape over, we see that this shape is composed of a few cylinders. 3 cylinders. First cylinder, second cylinder, and third cylinder. So remember that the specific weight of bronze is 0.318 pounds per inches cubed and of steel is 0.284 pounds per inches cubed. We want to find the weight and center of gravity of each part. For shape 1, that will correspond to this part on the picture. The weight of that shape is equal to the height of that cylinder, which is 0.40 inches, times the radius of that cylinder, which is 1.80 is divided by 2 squared times pi, because pi r squared is the area, and then the area of the cylinder times its height 0.40 gives us the volume of the cylinder. And then we have minus pi times 0.75 over 2 squared, because we want to subtract the volume of the inner cylinder, the portion belonging to the bronze. And then times 0.284, the specific weight of steel. So that is in turn equal to 0.2388898 pounds. And then because of symmetry, we don't have to worry about the x-coordinate of the centroid of this whole figure. We only have to worry about the y-coordinate. So basically, the y centroid of shape 1 is equal to 0.40 over 2, which is 0.20. So basically, breaking it down, this portion refers to the volume. This is actually the volume of the whole cylinder over here of shape 1, while 0.284 is actually the specific weight of steel. Next, we'll be focusing on shape 2. Shape 2, the weight of shape 2 is equal to the height of that cylinder, which is 1 inch, times pi times 1.125 over 2 squared, because 1.125 is the diameter and then half of that is the radius, minus the diameter, minus the area of the inner cylinder multiplied by its height. So minus pi times 0.75 over 2 squared times 1. And then we multiply this whole thing by 0.284 pounds per inches cubed, which is the specific weight. And we get that the weight of shape 2 is equal to 0.156834 pounds. Next, we want to locate the centroid. The centroid of shape 2 is composed of 0.40 inches, and then we have a portion 0.50 inches, because 0.40 plus 1.00 over 2 is equal to 0.90 inches total. The location of that centroid from the origin, which is the base. Now we focus on shape 3. For shape 3, we have that the weight of shape 3 is equal to the total height of that cylinder, 1 plus 0.4, multiplied by pi times 0.75 over 2 squared minus pi times 0.5 over 2 squared, and then times 0.318 pounds per inches cubed, which is the specific weight of bronze. We get that the weight of shape 3 is equal to 0.109269 pounds. And then the centroid we can find now by doing 1 plus 0.4 all over 2. As we can see, because that is half the height of that cylinder, and that is equal to 0.70 inches. A summary of the information we found: the weight of shape 1 and the y centroid of shape 1, the weight of shape 2 and the y centroid of shape 2, the weight of shape 3 and the y centroid of shape 3. All together, we get the shape, remember? And then the overall weight of the whole structure is equal to the weight of shape 1 plus the weight of shape 2 plus the weight of shape 3, and that is equal to 0.504993 pounds. And then we want to find the y of the whole shape by doing the y of shape 1, the y centroid of shape 1 times the weight of shape 1 plus the y centroid of shape 2 times the weight of shape 2 plus the y centroid of shape 3 times the weight of shape 3, all divided by the total weight of the whole structure, which is equal to 0.526 inches from the base. Summary of results. We originally were given this structure. We converted it into a 3-dimensional structure. Now we want to take a see-through cross-section. And then we can locate the y centroid of the whole figure as such by drawing lines. So that is the location of the y centroid of the whole figure. And that is in turn equal to 0.526 inches. So that is our final answer. Thank you guys so much for watching this video. I hope this video helped you guys out in your statics endeavors, and keep with me for more videos. Have a good day.